Yo, what's up, everybody? Welcome back. Today we're working on our window manager, Wayland window manager, low dependency, no WL roots, right? No lib Wayland. We're doing all of the chatter ourselves. We're doing like manual DRM, graphics initialization and all that. Today's topic is doing input handling. So here's where we're at. Let's give a little quick demo. We've got a VM open because oh, wait, wrong demo. Wrong demo. Hold on. Hold on a second. Wrong demo. One sec. Whoop. Whoop. Here we go. Okay, so we have, as of last stream, we were in a spot where we get one window, one client. He can come in here and say, please render me, sir. And we render him directly in the middle. What you're seeing here is like this red background is just proving that we can render like something in the compositor. And then this is like one window coming in, right? He's transferring some data over a file descriptor. We're like keeping track of that stuff, sending it back to him when we're done with it, converting it into an OpenGL texture, rendering it on the screen. The next steps here would have been to try to draw a window around this and like maybe move it around, maybe have two windows showing at once. But I was a little worried that that stuff might, like where I really will go to is like the next step after that would be doing input on the window. And so I kind of want to get like input handling set up first, because it will allow us to do things like drag the window around and test like that. So yeah, that's what I want to do today is try to get some form of like cursor on the screen and like kind of handle mouse events, right? What we're seeing now is we are seeing when my mouse is hovering here, we're seeing my desktop render a cursor above the virtual machine. If I click on the virtual machine, there's no cursor in there. And so I think, yeah, that's what we want to do is try to figure out how to get that in there. If you look up what other people do, everyone who writes a Wayland compositor uses this library libinput. I have like a very, very naive understanding of what this is. They kind of say, hey, if you want to have things that you input, we make that easy for you. Hand wavy, right? So things like two-finger scroll, I think are, handled by this guy, but I don't really know, right? So I think step one here is like, let's decide if lib input, the thing that everyone else uses, is something that we want to use, right? It seems like there's kind of like two worlds here, maybe three, right? World one is where lib input is kind of like a driver, right? So we might have the kernel interface to mice might be along the lines of, I'm working with a touchpad, and that touchpad emits, low-level details about fingers on it, but it doesn't really expose maybe like something at the level of like, I'm doing I have done a tap to click, right? Tap to click might be a feature that is implemented in user space on top of this, where you have to notice, you have to like keep track of the touch state with many fingers over time, right? If I do a two-finger click to right click, is that like, who's managing that? I would assume that's lib input, right? And my thinking is, I don't really want to write drivers, right? If all of these touchpads have like different responsiveness, right? And a two-finger click on one touchpad is completely different than a two-finger click on a different touchpad, I don't give a fuck, right? And so that's one of these cases where like leveraging the work of the world where everybody is using libinput and these people have profiled all these devices and have these like configs for them already set up. If that's what it is, then I probably want to use it, right? That's world one. World two is where they do all those things, but they do them badly, right? And so maybe I want to leverage like their information about how devices behave, but not their actual code to do the implementation of that, right? So maybe there's something there. And then world three is where it's providing nothing of value and we can just use evdev directly. But I don't know, right? So step one is to like look through what this thing is, figure that out. And then once we understand that, then we can choose, well, let's try to get some cursor updates. Maybe we're doing it with evdev directly. Maybe we're doing it with libinput. And then let's like render the cursor on the screen and maybe do something like keyboard input or something. But we'll see. We'll see where we end up. So that's the goal. And let's start poking libinput. Okay, so libinput is an input stack for processes that need to provide events from commonly used input devices. This includes mice, keyboards, touchpads, touchscreens, graphics tablets. Great. They handle device-specific quirks, right? So this is kind of like the thing that I'm worried about, not wanting to do myself, and provides an easy-to-use API to receive events from devices. This is like a little sketchier, right? Maybe they're like this is where they could be doing something like fucking stupid. There's like a good, but I guess I shouldn't say there's a good chance that they did something fucking stupid. There's a higher chance that they're doing something I don't like there. It's designed to handle all input devices available on a system, but it is possible to limit which devices it has access to. For example, to use this with this XF86 input with Zorg, it depends on snippets for devices, but it works best if it handles all input devices as it allows for smarter handling of features that affect multiple devices. Right. Sure. So like on my Lenovo touchpad or my Lenovo laptop, there's like the nub in the center that you can use for cursor movement. And like it's desirable that when you're using that, when your palm rests on the touchpad, you're not accidentally moving the mouse with your palm and your thing at the same time, right? So something like this might be what they're talking about here, where if libinput could only control one of those two things, then it would be a problem. But it being able to control both can do something, say something like, oh, I know that if I have both of these things, disable that one when this one's active, type shit. Restricts device-specific features to those devices that require those features. One example is the top software buttons on the touchpad in the T440. Well, there may be cases for providing top software buttons on other devices. Libinput does not do so. Sure. Introductory blog post describes some of the motivations. I don't really want to read that right now. This is not to support experimental devices. Unless a device is commonly available off the shelf, it will not support it. Libinput can be a useful base, but support will not land in master until the thing is common. It is not a box of Legos. It does not provide the pieces to assemble a selection of features, right? Okay, this is concerning. Many features can be disabled through configs, but some features are hard-coded and or only available on some devices. This is scary. There are plenty of use cases to provide these features, but libinput is not the place to support those. Okay. Not a showcase? Sure. So libinput is boring? Sure. So it's like things that are common, we try to make them behave sane. Hand wavy. Libinput is not used directly by Wayland applications. It is an input stack used by the compositor. That's us. We're the compositor. Typical software stack looks like this. So the kernel has event handles for devices. He slaps those through libinput, and then libinput lives in the compositor, and he sends input events to the client. Cool. We don't care about that right now. This is not a requirement for Wayland or even a Wayland compositor. Yep, sure. Libinput is not used directly by X applications, but you might use a Zorg handler that is based off libinput so that like things are consistent. Sure. Mice, keyboards, touchscreens, blah blah blah. He does not expose device type to the caller. Interesting. Solely provides the capabilities. Okay, so like relatively high level. Okay. So they've got like, yeah, things like button debouncing. Yeah, like stuff like this is like, this sounds miserable for us to implement, right? Like that just sounds like not fucking fun. ClickPad software, right? Like this also just miserable for us to say like, oh, on some touchpads that do have left click, right click buttons, but like some they do not, and they're kind of implemented in software on top of the touchpad, and you just have to click this one area. Like him, like knowing that, like maybe this is something where it's like, if this is easily accessible information that we could parse out ourselves, maybe like that seems fine, right? Maybe debouncing isn't that bad. We could have like generic debouncing. We could have, software click if something is easily definable for us. Gestures, dude, Linux has pinch. Okay, so like 3-finger drag, 2-finger drag, pinch, all of that stuff. So if we were to implement that, we would have to probably track individual fingers and convert those into high-low movements. Like that sounds pretty. That actually sounds like kind of fun, but I don't want to. Like not like out of scope, maybe. Sure. Swipes, holds, touchscreen gestures, middle button emulation for like 3-finger tap, maybe. Palm detection, thumb detection. Yeah. I mean, that's doing a lot. This is doing a lot of lifting. Tap to click, three finger. Yeah. Okay, so I think that there's a good justification here that, like, you could argue this is like almost like a driver, right? The Linux kernel interface is providing things like I prep my fingers on the touchpad, and this is turning that into they did a two finger click, they did a pinch, and our yeah. So that's one of those things where it's like in this stream, it would make sense for us to implement that stuff ourselves, but it's just like I don't want to. It's really the limit here. So let's take a look at libinput source code, or maybe that we should click on this, contributing to libinput, and he will tell us where the code is. GitLab, not GitHub. That is a large bag of dull misery. They weren't kidding when they said boring. Yeah. Okay. Let's just take a look here. We'll see how we feel about it looking at the source code as well. Can we do dep1? Shallow clone that motherfucker. And then let's also, in the virtual machine that we have, apk add libinput dev or something. And let's try to figure out what version of this thing they have. 1.28.1. Oh, so I should have actually not done a shallow clone. Fuck. rm-fr libinput. Git clone. Because I want to check out whatever version. There we go. Okay, libinput. So what was it? It was 1.28.1. Git checkout v1281. Let's see if that's nope. Git tags. Git tag. No V. No V on these bad boys. Okay. Let's just look around. Let's look at their header. What does the interface look like? Is this does not look like libinput. Maybe those are external includes. Input. Libinput. Here we go. So this is kind of like our entry point. So they have some opaque structs. Sure. We are probably like, how do we like initialize this thing? Do they have like API docs somewhere? Maybe that's where we start. API docs. Libinput exposes a single file descriptor. Okay, hype. That means that we can hook it up to our event loop. This should be monitored, and we call libinput dispatch. Initialization, they have either udev or like independently managed. I probably want to use udev. Dude, fuck off. Dude, how does this webpage look so bad? So we do libinput udev create context. So we probably need to like get a libinput somehow, right? How do we get like a libinput pointer? They have reference counting on libinput. Cool. You call dispatch on this thing. So you get this F file descriptor. You register the file descriptor with the event loop. You call dispatch when you get reads. How do you like fucking make the thing? Dude, what the fuck are we doing? I guess maybe we just call libinput ref. No, because we need a struct libinput here. How do we create this thing? Why only the menu in dark mode? Oh yeah, I guess that's what it is. Dude, this fuck off. I'm gonna lose my fucking mind. I'm gonna lose it. Okay, so here. So we get one of these things by creating a udev context with libinput interface. Okay, libinput interface. Oh, sure. So we feed in file descriptors for it's like configurable for how you call open and close. Sure. Do they have like a default interface? Instead, open restriction close are called for each path that must be opened. Yeah, sure. So no default. Okay, cool. So we create this udev context. It will manage udev stuff. It'll ask udev for all of the devices. Presumably then we call get file descriptor, monitor that thing, then dispatch. Cool. So then how do we get like events from this thing? Let's look for like pointer events, maybe? Like, what are we looking at here? We can ask for change in x and y or absolute xy. Return the x coordinate pointer in millimeters from the top left corner of the device. Interesting. I guess on a mouse, though, like on a physical mouse, there is no top left. No. Okay, let's take a look. Just at like the top level. So we know entry point. Okay, so our mental model right now can be lib input. Okay, we have like, I guess it's like this. We have like lib input, and we know on one end we have like create udev. We know we have like get fd, and then we have things like you know, get pointer dx, right? Which I guess is only coming in from an event pointer. So probably somebody is, he probably has, hold on, get pointer. So I see. So we call get pointer event on lib input event. So somebody is going to hand out lib input events here. So we're supposed to call lib input get event probably after like lib input dispatch. Okay, probably this will call something eventually. This function should be called immediately once data is available, blah, blah, blah. Return 0. So maybe not. Maybe we dispatch to kind of like service this thing, and then we call get event. So retrieve the next event from the eternal event queue. Yeah, so we're probably supposed to, after dispatching, we're supposed to call lib input get event in a loop, probably every frame of like every time lib input wakes us up, we do this in a loop, get the type. Based off the type, we can turn this into like pointer type, probably, right? So we get like an event, we say which type is it, and then he's gonna be like, hey, this is pointer motion. And if we see pointer motion, then we call get dx. Nice. Okay, that makes sense. Okay, so we kind of have like this stuff, right? Get event over here as well, like this type of thing, right? Then we know on the other end of lib input, there is dev, evdev, right? And the question is what is this path like? You know, is it like really fucked or is it like reasonable, right? I would like to know kind of ish how complex is this library? So maybe just doing like an approximate, you know, how many lines of code is this? 50,000. Okay, so that's an indication that there's a lot of stuff that it's doing in here, right? It's not like a few thousand, 50, and it's not like, you know, it's not like a million, but it is like, if we were to write this ourselves, it would take like a month, right? Just like eyeballing that, you know, we can, you know, we get like order of magnitude. Okay, so let's try to like piece together kind of like the base level. It looks like there's a bunch of evdev files actually, right? So this is kind of the lowest level where it's going to talk to the kernel. Can we look for like open evdev? Oh, they don't call open ever. Okay, sure. So like here they have some like udev tags that they're parsing. So they probably ask udev, hey, could you like give me all of the input devices? And if you tell me that this is a touchpad, I'll like flag this thing as a touchpad probably. Right? So like he's got some things that only work on touchpads, for example. Cool. Evdev configure device comes from evdev device create. So somewhere he's going to be iterating devices and trying to create them if they match some criteria, probably. Oops. Yeah, so here he's going to call dev node is probably udev device get dev node, and this is probably where the like evdev handle comes from. Okay. So like, evdev device create, who calls this shit? Udev seat, path seat. So we're gonna be a udev seat probably. So this is kind of a callback probably from the udev handler. Yeah, I see. So he's got some event loop, maybe. Or some like he's got some list of file descriptors somewhere. And yeah, so he's got his own epoll instance inside that he is using to register all of the guys he's talking to. Great. And so when the udev thing wakes up, he's going to call evdev udev handler, where he's going to be like, hey, you woke me up. What we got, if you see some device, I'll add that thing. Got it. Okay, not crazy. Not crazy. Here, he's doing a bunch of like udev management, and then eventually he like creates this device. This device probably is like an interface, right? Probably like this is going to be called for keyboard, mouse, touchpad, tablet. All of these are the same. I don't think Android is going to have udev no. I mean, for later. Yeah, so when we get onto Android, I assume that libinput will be completely replaced with something else. That's my assumption for now, but we could be wrong. So evdev device create. This guy probably detects the device type through the udev tags and constructs an appropriate interface, probably. I would assume where would that happen? So there's all of these like other things, right? We have like evdev wheel. Oh. Why aren't these sorted by name? That's annoying. Oh, because some of these are headers. Sure. So you have like evdev fallback device is probably the one that we'll be using most of the time. And presumably this implements some sort of like interface somehow. Not sure yet. Fallback, this returns a evdev dispatch. So I assume like struct evdev dispatch is hello? Oh, here we go. This has evdev dispatch interface, which has a bunch of function pointers in here. So here, this guy defines a bunch of commands that will probably happen when evdev events come in, right? We look for like process. When evdev events come in, we can probably assume that this is happening on read. Yeah, so every time libinput notices something come in on the evdev file descriptor, he calls evdev dispatch, which will eventually get into that like device specific interface. Cool. Okay, so we kind of understand that like there's a bunch of device types, right? There's like multi-touch touchpad, tablet pad, fallback, wheel, right? And he's going to call process on these things every once in a while. I would assume that this has to get hooked up to the other end somehow, right? So we kind of have like a bit of a picture of what's going on in here on this side, right? It's like we kind of have like ePol, we have evdev interfaces, as well as kind of like a base evdev handle. FD, this kind of like attaches to this and this somehow. We got like udev over here as well, who's also on the event loop. Presumably at some point, maybe like the fallback interface like propagates this stuff, right? So here we see some sort of like, you know, relative movement of the mouse, right? And if we have dispatch pending event here, so we have like dispatch, which is ourselves. This is like a unique type for the fallback interface. He's like updating real. So somewhere, somebody must be reading this thing, right? Right? Flush relative motion sounded kind of interesting here. Yeah, who eventually calls pointer notify motion. Right, so this is probably something higher level, almost like all the way up at the top of the base of libinput. He's gonna put this thing onto the event queue, right? Post device event. Right, this eventually gets to libinput post event, where this is probably just shoving stuff onto his internal event queue. And then presumably that like get event function that we call at the top kind of goes over there, right? So it's kind of like now we have the picture of, you know, this evdev interface is going to post events, right, over to some queue. And this queue is hooked up to get event here. Okay, so that's not like too bad, right? If we needed to get from like the top to the bottom, it's like 5 steps, right? We kind of like already understand that. So it's not that bad. What I'm more interested now is you know, where is it handling stuff like touch debouncing and stuff like that? Is that easy for us to find? Debounce, right? So this is part of the fallback interface, right? He does not, I get like probably debounce. Yeah, so he's got like a timer for debouncing. When that timer expires, debounce. Ah, I see. So this kind of lives somewhere else completely. Evdev debounce is called from fallback. I see. So in here, he has like some timers, and when they expire, they probably dispatch the actual event. Probably. Yeah. Okay. Okay. So I think at least from like a input to output hookup, reasonable. Reasonable. We think that based off the API docs that it is providing real value. We look at the code and we're like, there's a lot of code in here. We don't really know what all that code does, but I think that we can assume from reading just like this list of stuff here thumb detection, palm detection. Actually, I would like palm detection. That's kind of interesting. So a multi-touch touchpad, he might say in here, read palm. Yeah, right. Like, I know, like, this is crazy. So he's got like palm pressure property that is dependent on each device. Each device is going to have like a quirk that says like how much pressure do I consider enough, right? Apple, right? So in here, can we look for like palm in here? Palm size threshold, right? So this USB Apple touchpad has a palm size threshold of 1600, right? And he is going to put that in some threshold thing, and he's going to use that to detect init detection of this thing. So he's going to be like, hey, I guess this pressure threshold is going to be used somewhere else. Detect pressure triggered. So if this thing's over this threshold, then he sets the palm tracker state to pressure. Yeah, if you want more deterrence for doing this stuff, cat quirks in WCSL. Yeah. So 21. The quirks size is not that large, but it is, it is still a lot. Yeah. So like palm detection here. Oh my lord. Yeah, just look at this. Look at this. Fuck this shit, right? They're like, some guys do it based off pressure. Some people do it based off of if like the other thing was touched. Some people do like arbitration. I don't even know what the fuck that would mean. Arbitration state equals. Yeah, okay, so if he sees like this guy toggles touch. Oh, wait, hold on. That doesn't assign it. Oh, it does here. Oh, sure. So if you're like ignoring in a certain area, right? So like the palm is gonna like cover some segment, and if you're like you're in there, then you're probably fucking touching. Yeah, I don't want to do this. I think I'm willing to. I've seen enough. I've seen enough to say that at the very least, what I've read so far is like sane code, right? So far, it seems like I can follow it relatively easily. It's like kind of typical C style. They're doing a bunch of high level like shit that I don't want to do, and they have a lot of like device specific behavior that I don't want to handle. High level interface seems straightforward. I think we just fucking send it. I think we send it. I think I'm okay using this thing. Yeah. What are like the pieces that we want to think about, right? It's like if libinput developers stopped existing tomorrow, would I be okay with like continuing to maintain this thing? From what I've seen so far, it's understandable. It's a good starting point. I can find the path from input to output relatively quickly. And they're doing sane shit. So I think that's just like wins all around. Wins all around. I think the answer is we probably could. All this can be handled by the screen level by sensors. No, just process them after. So I think my understanding of the general rule of thumb is that the less you do in hardware, the better. The less you do in kernel, the better. Right? You want your hardware to kind of expose low-level details so that when something has to change, you don't have to respin the hardware, upgrade the firmware, any of that, right? The more that you can push like off device, the more flexible it is later. And then the kernel, it's like the same thing, right? The more you have in the kernel, the more surface area for problems there are, right? And so like you can I think it's reasonable to have a user space segment of drivers. I think that's reasonable, and I think it's reasonable that this is where that lives. Okay, let's try to use it. So, I guess we need to link against libinput. Are we in the right environment here? Probably here. So somewhere we huck input here. We probably need our environment here. To have lib input for local development. We probably want to assume that our lib input will only be used in the case where we're running on like bare metal, right? So we need to be able to optionally turn that off for testing when we're not in our virtual machine. So we're probably like app structure is going to look something like we have like our event loop, right? He's going to hook up some like input interface, right? And this guy is going to have like a file descriptor as well as like stuff. We don't know like what like stuff is yet, right? But this input interface is going to be implemented by like lib input backed and null, right? For if nothing is available, and eventually Wayland, right? Eventually, we are going to support running a Wayland compositor on top of another Wayland compositor, in which case we'll get the events from like the window manager itself, right? But for now, if we implement these guys, it means that we'll be able to keep running and test that everything like, on the Wayland side works, but be able to use lib input when we're on system or like on a system that bare metal, sorry, on when we're like in a virtual terminal, I guess. I think disappears tomorrow is not entirely unlikely. At least a few years ago when I read about this, so you might want to choose your words wisely. Classic XHCD 347, as far as I recall. As you say, everyone depends on it, so it won't die anytime soon, though. Yeah, that makes sense. Makes sense. I mean, I meant to say that, like, I wouldn't want to maintain it for everyone else. I think I could maintain it enough that it keeps working for me, you know? That's really more what I meant. Okay, so we have libinput linked somewhere, I think. We should be able to use it, right? So somewhere we probably need to generate some zig bindings for this stuff. So, something like this. Input bindings input. And we say here, input comes from input bindings. Boom. So we need to do source. This guy needs to be input bindings translate C. And we need to edit source sphwim input h and include libinput.h. Looks like it. Okay. So now somewhere, we in main have to initialize some input backend. So I guess we're gonna have like source input zig here. And here is where we're gonna have like our interface, right? So we're gonna have like initialize interface, right? And this guy is going to try to open lib input, fall back on null input handler, right? It's gonna be something like this. So we're gonna have some sort of like input handler, and he's going to have at the very least a file descriptor that he can register with the event loop. Something like this. Stud is import stud. And he's going to have some vtable, right? I don't know what that is yet, but at the very least, we know what interfaces do we know exist in lib input? We know that we have to dispatch, right? And we know we have to call get event, right? So I think what we can we have like a couple options here. One is that we feed the input handler our compositor state, and he like directly modifies it. And I don't even have to explore other options because that option is great. Let's do that. So he's gonna have some like service function. Uh-huh. And he is going to take in compositor state, probably. Compositor state zig. Oh, this is in the wrong folder, by the way. This thing needs to go in sphwim, the window manager. Okay. So he is going to be like, compositor state is compositor state. This is kind of like the hub of everything that happens in our app. And I think that's kind of it. This thing surely can fail. And then this thing is going to pass in the file descriptor as well. Like this. And then we're going to have like service here. Compositor state, compositor state, return self vtable service self context self fd compositor state. Boom. Easy. Yeah, okay, here. Context is any opaque pointer. Boom. And that means that I thought that vtable was going to be a little bigger. For now, we'll kind of do this like this, and maybe, you know, in the future, this turns into a vtable. Oh, we can't do this because name collision. Fine. Fine, we'll hide it behind a vtable, even though the vtable's one thing. Okay. So now, I guess here what we'll do is we'll have like lib input handler, right? And he is going to have some function service that implements this, right? Boom, bang, boom. Who fucking knows what he's gonna do? But we know he's gonna exist. And this is gonna be like, you know, he's gonna be like, lib input. Here is import, input binding. Is that what we called it? Input? I don't remember. Looks like we called it input. So he's gonna call this like this, which means that he has to hold a lib input here, right? So this is like lib input, boom. Straightforward so far. So this is one of these guys. Boom, boom. And this thing, I think, can return failure, right? So if this is not equal to 0, I assume. We could look, though. Lib input, dispatch. Okay, so this returns 0 success, negative or no on failure, yeah. Cool, so this is not equal to 0. We do, like, return error, you know, failure, whatever, and fix me, parse, you know, failure or no, but we're kind of stubbing it out for now. And then we're going, like, while true, we're doing, like, lib input dot lib input event, next event, or something. Lib input event next. I forget. Get event. It was lib input get event. And then this guy probably takes the lib input handle. Yep. If next event is null, I guess it's like next event is next event opt, or else break. Great. Then we're gonna say next event type is lib input of get event type, maybe? Yeah. Where... Oh, wait, hold on. Whoa. Surprising that this doesn't take in what we expect there. I would have expected it was like, oh, here we have event get type here that takes it in. Okay, cool. Cool. Libinput event get type. And let's kind of start here by just logging this thing, right? Log debug got event for this. Right? Let's just kind of start there. Let's start there. Okay. I'm surprised we don't need the file descriptor here. I guess libinput holds that internally, and we don't need the compositor state yet either. But eventually, we may want those things. Okay. Cool. So now we just need to get one of these, right? Which means that we have to try to initialize this thing somehow. So we're gonna call like libinput, what is it? Udev create context. This returns us a libinput, right? So libinput is this, and or else return error create context, right? Boom. Otherwise, we're fucking chilling. This guy initialized. We're good to go. Okay. Easy. I guess this is name colliding. So input context, we'll call it instead. Boom, boom, boom. Okay. So now we're good to call, this thing is going to return a input handler, right? Which means that lib input handler needs to live on heap, right? Because this is going to return like a generic interface. So this guy's going to take an allocator, and he's actually going to first create. He's going to do like ret is try alloc create lib input handler ret.star is equal to this, and then return ret handler or something, right? Maybe we don't even have to do that. If we're just returning this thing directly, we can just return an input handler here, and we can just kind of construct the vtable here, right? So we have pointer is ret, or context we called it here. We have file descriptor comes from, it was like libinput get fd, right? Yeah. Boom, and then we have vtable is simple. It's just service is service. Boom. Crazy. Okay. Cool. So this guy needs an allocator then. And for now, we're just going to return try lib input handler init. But we are kind of ready to implement the null handler if needed. If needed. Okay. I think we want to call this backend, actually, is a better word for this. Because I think input handler is what we're going to call the top level guy who like registers with the event loop and all that stuff. Initialize backend. We'll call it. So here in main now, we can kind of say like our input backend is try const input is import input.zig. Wonderful. We're going to make some backend with root alloc, probably lives here. And we're going to register this thing somehow. So we're going to be like loop register. I guess, okay, so we have the back end. Great. We need the handler now. So input handler is going to implement our like epoll interface. So we have somewhere we have epoll handlers. So they need to implement these functions. You know, what is he going to do on poll? Right? And what is he going to do on close? Boom. Okay. So this, he's going to have like his backend here. Input backend. Boom. And this guy needs to import stud to implement this thing. Okay. Cool. He's like, I have some event loop, poll reason, poll result. And for now, let's just assume that we can just kind of unconditionally call self backend. Oops, this is an input handler. Can we just assume we can call this? Okay, easy peasy. On close, we probably do this, right? Which means that our backend needs something. Okay. This probably looks something like this. Oops. Yep. So this is our close function. This guy needs to implement close now. And his close is going to close the lib input handle, probably. So it's like lib input, destroy, close, free. What's the fucking API gonna be? What's it gonna be? Oh my god. Lib input unref, probably, right? Probably something like this. Something along these lines. We'll have to think about. It might make sense for the backend to not handle compositor state directly. It might make sense for this thing to kind of return like what happened and for us to convert that into compositor state. But I think that we can get a little bit more fancy with that as we need. We'll see. Okay. This UDEV create context. What we got here? Interface, user data, UDEV. Okay, so interface. Here we need to implement open and closed, right? Open file, close file. And do these guys have like use data? Yeah, they do, right? Yeah. But I think we can just get away with going like open file takes a Path? Oopsies. Oopsies. Oh god, what have I done? What is happening? There we go. Okay, so this is like this. So what does this guy implement? What are these? This is probably the path, right? But I don't know what the rest is. Okay. Flags as defined by open2. So we just fucking call stood POSIX open. I don't know why they're fucking making me do this. But whatever. Flags. So just like stood POSIX open. Flags. Can we just call the fucking native version of this thing? Like, this is just system open, right? Like, can we just do this? Like, fuck it. He does want a mode. What does that do if we do stood POSIX open? Oh, we're supposed to pass this in here too. What are our modes here? Man to open. Mode. I think I just huck a 0 in here, no? I think it's just a 0. Probably like this, right? I assume it's like this. With the user data if we want it. Okay. This guy, he wants bitcast. And this guy wants mode T, which 0's allowed, no? Okay, here we pass this thing in here. Which this thing needs to live like in global space. We're gonna need to make sure that this is like lives forever. Okay, he wants user data, which will pass in a null, and then he wants a udev context, which means that we need a udev context, which means that we need to like call udev somewhere. Right? Do you have like an example in here? We also need to assign a seat. Okay. So where the fuck do we get a udev? udev. Hopefully this is easy to make as well. This I want like C also. None of these. All right. I guess we add udev here. libudev? Probably? I don't know, man. Let's see. I don't know. Let's just start typing and figure it out. He's like, nope. NixOS package search. What we got here? udev. libudev. Okay. That's not what I want. I'm more curious, like, how the fuck do I use normal udev? Systemd udev? udev. It's crazy that this isn't easy to get. Is this defined by libinput? Surely not, right? Libinput getting started. Quick start. Not helpful. Topics. Initialization. This is not helpful. Okay, where is like struct udev? Like, where does this come from? Is this like, who owns this? libudev. Who owns this? libudev. Yeah. Okay. Sure, this makes sense. So why the fuck? Like, is that not something that I can get here? Run system, run current system user, like, can we look for like software lib udev? Yeah, okay. So where the fuck do these go? Systemd owns it. Systemd owns it. Okay. So does that mean maybe in here we need like systemd? Is that what this means? All right. Input. So can we like include libudev? Nice. Nice. And so can we then go back into like system input zig? Can we call this like system? Boom, 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 boom. Okay. So we need to make one of these fuckers. Looks like udev new. All right. Let's not think about it more than that. Udev context is system udev. This is a pointer, right? Yeah. System udev new, or else return error create like udev in it or something. Cool. We're getting close. Udev context is udev context here, and then when we close system udev unref, udev context. All right. We're getting closer. This guy's mad that we don't use this yet. We'll figure that out in a second. This guy's mad. Whoa. Do I not need to pass that? Maybe I don't. Oopsies. FDT everywhere. Okay. Close is mad because this thing isn't supposed to error ever. Sure. Unref. Return something. Kind of fuck it. I don't give a fuck. I don't give a fuck. Okay. Now we need to link against udev? Holy. Okay. Undefined symbol udev new, but I'm linking against it, no? It's the right spot? Uh, caching issue? No? Alright. Can we look at this thing? Udev, I mean, surely this exists here, right? So what the fuck is going on? What the fuck? Do you think if I type it again? Do you think if I build it again, then it'll work? Sphwim, udev new. This is in make wm. I'm saying fucking exe link that shit. If I like fucking type udev a, he's like, I can't find that, right? So he is resolving libudev correctly. I don't understand. I mean, am I high? I don't see -l udev on here. I see -l input. Am I fucking high? Right, L input's there. L udev is just not there. Oh, hold on. Yeah, okay, he's here. What the fuck? What? Why? Why are you doing this to me? I can't tell if I'm fucking stupid or not. Right? Like, how could I get more explicit? Like, what the fuck is it doing? He adds a system live link object who presumably he iterates these things later. Right? So in like the compile step, probably. Right in here. Was it link? I already forgot the name of the thing we were looking for. Link objects, right? So if he looks for these things, when he is built like extracting zig args, he should throw this on here. Right, prefix here. And he should just append this thing, unless package config. In which case he might be doing package config cflags libudev or something. He might be doing something like this. But he would be resolving this. So all of this is confusing. All of this is confusing. Can we force no package config for a second just to see if that changes behavior? use packconfig is no. Fuck off. Yeah. Um. We might not have the package config rules in somehow. Somehow, I don't understand how if I type package config. Maybe it's like this. Yeah, there's maybe something there. Hold on. If I type libudev here, kill me. That's crazy. So package config libs, garbage fails. Package config libs udev succeeds with nothing. But if I type libudev with package config, then he gets it. That's crazy. Why do we need udev though? Wouldn't we just reference the links in proc for input? Why does it be translated for the compositing stage? So there is no input comes from handles to the kernel in dev of ls dev input, right? We have a bunch of event handles here. This is where when I wiggle my mouse, something comes in. There's no proc handle to the mouse, right? We need to get these events here and put them somewhere else. So udev tells us udev is how we iterate these things, right? We could also manage these paths ourselves and hook them up to libinput manually, but udev is a system that tells us, hey, a mouse just got plugged in, and here is his event handle, and he is a mouse of this type, and here are the extra things that you might want to he has there are udev rules where you can attach extra attributes to certain devices and stuff. So all of that is stuff that libinput will parse for us, and then create, export libinput events based off of the devices that udev told him about. Okay. This is so weird. Everything else you don't put lib in front. So I think this is package config rule bugs, but whatever. Oh, this compiles. So probably now, I assume that if I try to run this now, oh, we do actually succeed. That's surprising to me. Oh, because I think it said nothing happens until you assign the seat, right? We saw something about that. Lib udev assign seat. Have you tried running a random Wayland app under your compositor, something like console? I tried using running a GLFW app, and there are some things that we don't implement yet that we have to. But we'll get there. We'll get there. So what is seat ID here? What the fuck is a seat? My understanding is that when I'm on a Linux system and you have multiple users, when you type switch user and you switch between virtual terminals with Control Alt F whatever, you are each user wants access to the same resources, right? They want exclusive control over the monitor and the mouse and the keyboard. So my understanding is seat management is systemd has a daemon that is running that you can ask to be hey, I want control of this shit. Can you just tell everybody else to let the fuck go of that thing, and then maybe let me have a turn? Maybe, please, sir. Can I please have a fucking turn? So I think that that's what this is, but I don't know what the seat IDs are. Is it just fuck it? Whatever? I guess we can try it and see what fucking happens. Right? So system lib input udev assign seat input context sphwim. And maybe this is supposed to have a user. Who fucking knows? Surely if no inputs are currently available on this seat, surely there are seat names, right? What are system d seats. Maybe? Property of ID seat. If not set, the device is assigned to seat 0. Also speed up enumeration of hardware. ID seat Waldo. Maybe like M rep seat. That seems interesting. Why? How come if I search XGG seat, am I fucking stupid? Seat. Oh, here we go. Seat name, the session shall be registered for, if any. So I guess we are supposed to use this. I think. I don't know. We're kind of just flying by the seat of our pants. Process env. Get env var. Get env. Can I just get like a single environment variable? I don't really want the fucking whole map. What do I do in create Wayland? Manzig Wayland. Oh, stood posix get env? Sure, let's do that. XEG seat. Or else return error, no seat. If this is not equal to 0, I assume, return error assign seat. All right. Okay. I would have thought that this should fail. Because, like, this guy should not succeed in getting the seat, but he is logging hello, so we are getting through this. So maybe stuff is happening. Maybe. I guess let's try to use this handler and just see what fucking happens. So here, we should be able to say, we have our input backend somewhere. Can we make our input handler? Input handler. Backend is input backend. And compositor state is compositor state. Cool. And then we register this thing with the loop. So loop register input handler handler. Okay. This thing returns a stood event handler. FD is self backend FD. Pointer is self. VTable is VTable. I guess it's more like this. Poll is poll. Close is close. All right. Loop doesn't exist yet. Loop's down here somewhere. What's he pissed about? Handler's not marked pup. Well, fuck you too, man. Fuck you too. This thing is mad because I'm just calling the wrong function here. Okay. This guy wants to use try. Return complete. Will stood log. Error failed to service input backend shutting down or something. Maybe that's an overreaction. But fuck it. All right. So is this ever happen? Like, is anything ever happening here? That's the question we should be asking ourselves. Is does anything happen? Std debug print libinput stuff happened, right? I would assume no, but I would also assume that this doesn't like. Oh, here we do get libinput stuff happened once. Oh, because we call off rip. Sure. But then otherwise, no mouse movement or anything causes anything to happen, which is like what I would expect, right? I would expect that libinput should fail to initialize on this system because like we're not like the exclusive owner of that shit, right? So I think we're missing a step somewhere where we must have to ask someone to like give us control. I would have thought. I'm curious to what happens if we run this in the VM, right? It might be interesting to see. We don't have libinput in the VM yet, or we haven't synced the like file system over. It's probably more likely. Sync rootfs. All right. Let's try again. All right, let's see what happens. If, okay, error no seat here is like interestingly, oh, sure, because we need xdg seat 0 or something. Okay. So the question is, can we fucking stop spamming with the render logs real quick? Just get that shit out of there. What are we spamming? Rendering buffer debug rendered after. Failed to call FB. I mean, can we just turn off logs? That's probably easier. And then just make sure an input side, we're just printing. All right. Okay. Okay, so that's interesting. That rendering buffer thing is fucking annoying. But if I like go in there and start moving the mouse around, shit happens, right? So, right, like things are happening, which means that like we're doing something relatively correct. I just need to figure out why we're not like erroring out when like initialization is failing. But that's like a problem for later, probably. Yeah, like fix me. Seat initialization should fail on my desktop. Why isn't it? Okay, or on my like in Kwin, I guess we should say. Okay, but it looks like we have some stuff. So I think the next thing to do is to just try to like figure out what those are. Oh wait, no. We're saying libinput stuff happened, but no events are happening? Oh, this is log debug. Can we I would love actually to figure out how this like logger system works. Can I set like which modules? Like what the fuck is a log scope? How the fuck does this work? Scope comes from this? Who calls log enabled? Log here gets the scope from here. So when I call stdlog debug, he gets a scope from scoped. Oh. So here we go, I guess, into... We're supposed to, like, inject logger scopes where we want, right? So we want to go, like, input here. And we want, like, input logger is std log scoped input or something, right? And I think this probably can live like all the way up here. And then here it's like input logger debug. Yeah. I see. And then at main, we have scope, like log scope levels. And in here, we say like input is equal to debug or something like this. Scope, it's like this. Like this, maybe? Feels right. Oops, wrong place. Cross compile this shit, copy paste the VM, run that shit over here. There we go, nice. Nice! That's hype. Hype! So now in our like input handling stuff, we can just use whatever. Okay, so actually I wanted to see as well. I go here, I press keyboards, I get 300, mouse click 402, mouse movement 400. Cool. Also, this is funny. Input isn't disabled for the virtual terminal somehow. So it seems like that's a fucking bug. My weak understanding is if on SSH-X server X app, the relevancy is on my end where the hardware and the X server is. That's confusing. That's confusing. Okay. So, do we need to call something to disable that? I guess for now, we'll just be like, just throw fix me there. Fix me. Input events are still going to my VT. Like, maybe that shouldn't happen. Smile. Okay. Let's try to like handle the cursor position though. Let's try to handle the cursor position. So we're looking for, I guess we know what the number is, but we don't know what that means, right? So it's like, what was it, 300, 200, something like that. Event type. Pointer motion. So pointer motion, pointer button. So eventually we might have to support these things, but we have relative pointer motion here. So let's figure out how to use that thing. So we have event pointer, get dx, get dy. So I guess, oopsies, we just have like in our compositor state, cursor pause. What unit is this thing look like it's in? DX. Fuck off. Double. Double, double, double. Okay, and then return the delta between the last event and the current event. For pointer events that are not of a type this function returns 0. If a device employs pointer to acceleration, the delta returned by this function is accelerated data. Relative motion data are to be interpreted as pixel movement of standardized mouse. Cool. All right. So we just go into like input zig here. I guess compositor state here. We have x, y, and we're gonna say notify movement probably. Dx, dy, and we're gonna say like self x is self x plus dx clamped to window you know, window width, probably. Window height. Which means that this actually moves up a level because we need more information than we have in the cursor, but surely we have enough information in compositor state, right? Notify cursor movement, right? And by window width, I mean compositor like this, maybe. DX should be changed to DY. Yeah, so true right now. So true. This guy gets a cursor pause. We have compositor width here. These are probably U32s. And we have these on initialization. Compositor width. I guess we can ask the backend for this thing, technically. Can we store these as like we have like render backend current resolution. But we already called this somewhere else, so we can just pass that in. Like, fuck it. Oopsies, wrong place. Referred size. So, current res is rendering resolution. We store that thing here. Compositor res goes here. And cursor pause is maybe like X is current res over 2, Y is current res over 2, or width over 2, height. Probably need to do some like float from int shit. Okay, but otherwise it should be good. This is mad because I didn't save yet. So true. And then I guess we need to call that from the backend, right? So in input, we say switch next event type, right? If, yeah, else, we can do this. Unhandled input event this. Easy, but if we see system lib input event pointer, was it pointer motion? Yeah. We can say, do we need to free this, by the way? Event destroy, yeah. Okay. So here we say system, we say, I guess here, state, compositor state. What language is this? Zig. Zig, zig, zig. Notify cursor movement with dx, dy, and we just need to get those, right? So this is system lib input pointer dx or something. Yeah, here we go. So this is the pointer event. And then I guess it's probably fine. To use floats, it's probably fine. So we need the pointer event is lib input get pointer event. Yep. Hype. And I assume that this is like a cast, right? I assume that this does not need to be freed. If I were to implement this, that would not need to be freed, but we should check. return a pointer if the point event does not match pointer types, the function returns null. Wonderful. And then he doesn't say anything about freeing here. But we do need to free the stuff called by get event. Okay, cool. That makes sense, right? Because this is probably just like this is probably like a union that's just getting cast or something. This shit's probably mad because the float type's wrong. Yeah, so do we do like a float cast here? Okay. And then this shit is unhappy. Why? Because there's no field X. Oh, because this should be cursor pause dot. Okay. No field name X in compose state. So true. So true right now. DX to DY. Did I do it again? You guys are so rude. You guys make it sound like I'm such a fucking idiot. Why are you such a stupid fucking idiot? Oh, god damn it. Alright. Float from in. Okay. Oh my fucking god. Fuck this shit. As F32. There we go. Okay, let's see. I guess can we also log the cursor state? Maybe in each frame of rendering, because this is where this is eventually gonna go. We should log the cursor position. And then while we're here, actually, can we do logging here as well? Like a scope logger? Question, what are you making? A window manager. We're making a window manager. Wayland window manager, low dependencies. We should start writing down dependencies. Not WL roots, not lib Wayland. No these, but we do have lib input and OpenGL. Like KDE? I mean, KDE is a lot more than a window manager, but like Kwin, yeah. Like Kwin. Okay, so can we do like logger is stood log scoped with rendering like this? And then can we look for stood log and do a little logger like this while we're here? And then we can do logger debug cursor pause like this. Okay. And then in our main, we can turn back on debug logs for everyone. Boom. All right. So I move my cursor up to the left, down to the right. So what's concerning here is like when I leave the window, so the clamping is kind of working, but like when I leave the window, it means that the cursor like it doesn't necessarily track the tablet cursor very well. So I feel like I've seen before that there are like absolute pointer positions as well. I don't know why we're not seeing that. Right? Like I feel like do we need to ask for it or something? Or maybe I need to enable some driver in the virtual machine for that to work. Can we fucking stop spamming lib input stuff happening? Like, who gives a fuck, dude? Who gives a fuck? Do I have on movement? I don't know what you're asking. Okay, so we are not seeing events for anything but relative movement, right? So I don't know, like, it's very possible that like for QEMU, like what is my like default mouse, like tablet mouse or something? Is something that I've seen before. Mouse. USB tablet. I think this is better. Right? So can we just be like device USB tablet in our virtual machine run? Hello? No USB bus. How the fuck? QEMU USB tablet. You are in such a VM, but I think I'm not doing it by default. I think it could be. You know what I mean? So I think we go like this. Fuck it, whatever. I don't give a shit. All right. Let's see if that changes anything. Yeah, so now I'm getting absolute events that we're not handling. Wonderful, dude. So let's turn those on. So if we see pointer abs, what was it? It was something like that. Pointer motion absolute. Here, we're like, we can have notify cursor position here. Cursor, cursor position. And we still do the same clamp, I think. Or else it'll like go too far. But now we can do this, right? So we have probably a pointer event still. Cursor position. Is it like get X and get Y or something? Input H, lib input, motion absolute. This is get absolute X on a event pointer. Sure. Hello. Input zig? Oh, this one. What was it? Get absolute X? Whoa, what is transformed for? Transformed to screen coordinates in millimeters. We want screen coordinates, right? But how does it know what the screen... Oh, wait, we can tell it. Hype. Hype, dude. So we use this with... It's compositor state. Cursor pause... Or no, the... current resolution, compositor res width. Yeah. And then this is with Y and height. So it is kind of good looking at this now. It feels correct that we pass the compositor state all the way to the back end, right? Like he really does need to like poke and prod this thing. Yeah. All right. So we should, let's fucking close the shit. Okay, so now we are not logging the cursor position anymore. debug log level. All right. So now I come in from the left and we immediately snap from like pixel 179. Yeah, I'd say that's working. Feels pretty good. I forgot that it like tanks my bitrate though. Like, sorry guys. Okay, so now we have to just fucking render the thing, right? All we gotta do is render it. Yeah. So for now, let's just get real cheeky with it. I don't really give a fuck right now. What if we just render an invalid texture somewhere? That's the easiest way to do this right now. So we say cursor pause. I think we just call like so we say every frame, sir, I would like to do this after we clear. Great. And probably after we render all of our windows too. The cursor should be like maybe the last thing we fucking render. We might want to use like a cursor plane here. I think that there's like hardware rasterization for cursor plane is a thing that I believe DRM supports, but fuck it. And I guess we just say image renderer, render texture. Can we just do like a invalid here with some transform? And this is a scale relative to. So we first put this thing in the fucking center of the screen. So we start with, you know, a full screen render. Is what this thing typically does. So then we scale it down so that it's like this, and then offset it so that the top left corner is in the right spot, which we could do before or after. And then offset from here relative to the cursor position. So it's like translate by self compositor state. Can we do this? Const. We have like the resolution is self compositor state current resolution here. So we translate by resolution width over 2, height over 2. As F32 return float from int. Okay. Okay, so we move this thing like that. Then we scale by like 20 out of resolution width and resolution height to get it by a 20 by 20 box. Then we translate it by 1010 to get the top left corner where the cursor is. Okay. And then this is like half res is this. Half width, I guess. We calculate here. Half height. We use that here. Wait, is that true? Yes. Then scale it down, then translate back to like negative half No. This is in the wrong unit. We're in OpenGL space first. So this should be... I think we want width here. Like this, I think. Not sure. 10 out of... I think it's 10 over half width. I'm not sure. OpenGL space is confusing. It's double the size. And then it's like move this by -1 to get it to the top left corner. Offset this thing so that the top left corner is in the right spot, and then offset it again so that it's at the cursor position. Sure. I think it's like this. I'm not sure. Feels like it's something like this. Let's just see. We can always debug if it doesn't happen to be right. It probably won't be right. Oh, we're so close. It's just upside down. It's just upside down. Because Y is upside down in OpenGL land. So I think we just flip. Oops, this one. So here, what the fuck? Clearly not. Maybe minus here. We could actually think, use our little brains for once in our fucking lives. Yeah. I think we do have to do that. We have to use our brains for once in our fucking lives, man. Okay, so this translation should be negative here to get the top left corner into the corner. Okay. I'm gonna say 0 here for a second so that I understand. So this should make a black box that is always in the center Y, but matches my mouse's X position. Yes. Okay, so that's all correct. And now all we have to do is bring back Y adjustment, which is put them in the top left corner, which means +1 to go up. Then go back down by the box size. And then add 1 minus this, I think. Which probably can get optimized in some way, right? But like, so my distance from the top is... No. This is just a minus here. To get closer to 0. So if I am at the bottom of the window, I'm to make it all the way down or something. Yeah, that sounds maybe right. Fucking graphics, man. Fucking graphics. Is that right, though? All right. Yeah, I mean, we're close. I think that the offset is wrong. Somehow. Like, it feels like this is wrong. Maybe it's here. I was supposed to be using half width units. Might be something like that. No, it's still not tracking right. So here, cursor position is 0, and it's showing a little bit to the right. What am I doing wrong? So if I do this, it should be like the center of the box matches my cursor position. Right, so I come over here. Oh, interesting. It's already the top left. Oh, because when I did the offset, I offset so that the top left corner was in the center, so the scale already matched that. So I did that part was already done. I see. Okay, wait, no, that's great. Look at that. Look at that. Look at fucking that. So now if I hook up a client, I should be able to see the little guy show up, and I should be able to kind of hover my mouse on top. And so, like, theoretically, if we wanted to do, like, window movement now, I could do this by, like, I could, like, click this window, figure out where I clicked, and then, like, drag it around. That's perfect. That is perfect. And I think that is a great place to call it for the day. Yeah, that feels pretty good. Thanks for watching, guys. I hope that you enjoyed. If you like what you saw, we stream most days. We aim for 12:30 to 4 o'clock Pacific time. It is 4:10 now. We are working on this window manager. And so if you want to check that, we stream most days, or there's a YouTube link in the Twitch description if you're watching live, where most feature development should go up. Some aspects of the coding do not go up there, like cleanup and stuff. And we do that because, one, it's too much content to post to YouTube, and two, it gives us something to give people who want to support the stream. So, like today we were working on trying to make sure that the WLAN buffer flow was correct, so that we don't like crash, and so that we don't not like leaking memory. Oh yeah, and that stuff goes up on either you catch it live for free, great, or it's on YouTube, Patreon, or Twitch. If you pay in the appropriate place, you get VODs in the appropriate place, and you get the VODs and the knowledge that you're helping the stream continue. Because one day it will end when I run out of money. But for now, that is not the case. Okay, cool. I think that's all we got to plug. YouTube, peace out, and Twitch, let's find someone to raid.